Abicon tutorial.
Good day, listeners. Today we are considering the application of Euler method in solving second order initial value problem. So the initial value problem that we considered is as shown. We have a d squared x dt squared equal to g minus cg over m dx dt all squared. So, and there with the conditions x of 0 equal to 0 and dx dt of 0 equal to 0. So we are given that t is equal to 10 seconds and then the step size is 2 seconds. The values of g, cd, m are given as shown. So that means for the step size 2, we run from 2 to up to 10 seconds. So let's see how we can solve this. Well, the first step is to convert our second order IVP to convert it to system of first order differential equations. So we say let v equal to the x dt, and then if we differentiate v with respect to t, so we're going to be having the v dt equal to, so we differentiate these two, so we have the square x dt squared. So then it means that the two system of equations are, we have the x that is from here, we have the x dt equal to v, and the second one from here, the v dt equal to the square x dt squared. Don't forget that the square x dt squared here is same thing as g minus cg over m dx dt squared, like this. So now we can then write the system of equations that we have out as the x dt equal to v, and then the second one, we pick this, the v dt equal to the square x dt square, which is the same thing as this. So g minus cg over m dx dt squared. This is incomplete if we do not include the conditions. So we are giving the initial condition x of 0 equal to 0. So we bring that here, x of 0 equal to 0. And then the second one, the x dt of 0 equal to 0. Don't forget the x dt here is same thing as v. So instead of writing the x dt, we change it to v because our dependent variable v here. So it's going to be v of 0 equal to 0. So these are the system of equations we shall be solving using Euler method. So here, now, using forward Euler method, this can be written as x n plus 1 minus xn, that's the derivative over the step length equal to v. So let's represent that as vn. So what we have here now can be simplified. This implies that xn plus 1 minus xn equal to hvn. And then finally we can have xn plus 1 equal to xn plus hvn. So this is the first one. Then the second one can equally be written using forward Euler method as, this time around, this is v, vn plus 1 minus vn over h equal to g minus cg over m into the x dt all squared. So from here, we simplify. Simplifying, we have Vn plus 1 equal to Vn. Don't forget, H will have multiplied the whole of this. So we have plus H multiplying Cg over M dx dt all squared. So this is the second one too. So let's write them out now and begin the solution. So we have xn plus 1 equal to xn plus h vn. And then from this one, for both of them, h is 2, and then c naught is 0, and then x naught is 0. That's for the initial, from the initial condition. That says that this is our initial condition for this one, x of 0 equal to 0. This refers that c naught is 0 here, and then our x naught is equal to 0 from here. So then for this, the second one, Vn plus 1 equal to Vn plus h Vn h g minus cg over m, our dx dt, our dx dt too here. We shouldn't forget that the x dt is v. The x dt is v. So here, this will be written as vn squared. Vn squared, all inside the bracket. So from here, we now say at n equal to 0. We shouldn't forget too that h is equal to 2, c naught is 0, and then v naught is 0 from the initial conditions. So when n is 0 here, from the first one, we have x1 equal to x naught plus h v naught, and this implies that x1 is equal to our x naught is 0, 0 plus our h is 2, 2 multiplying v naught is 0. This implies that x1 is 0. Then for v1 is equal to v naught plus h g minus cg over m v naught squared. So introducing the values, we have v naught is 0 plus h is 2, g has been given as 9.8, cd is 0.25, and m is 65. Multiplying v naught. V naught is 0. So simplifying this will give 19.600. So this is this. Then when n is equal to 1, we have this becomes when n is 1, this becomes 2x2 equal to x1 plus hv1. Then we begin to make substitution. So we are going to have x2 equal to x1 plus hv1. This implies that x2 equal to our x1. We have obtained that before. Our x1 is 0 from here. So 0 plus our h here is 2 times v1. V1, this is v1, 19.6. Simplifying this will give 39.3200. For v2, we have v1 plus 2, which is our h, 9.8 minus 0.25 over 65 times v1. V1 squared. So from here, our V1 is 19.6. We obtained that 2 into 9.8 minus 0.25 over 65. And then our V1, we got that to 19.6 all squared. So simplifying this will give our V2 to be 36.244. So we can continue the process to obtain the values of x3, v3, and so on like that. So if we continue the iteration, we have x3 to be 111.688 and v3 will be 45.739. And then for x4 will give us 203.166. V4 will give us 49.246. Thank you for listening.